Alright, so welcome back to your favorite inorganic tutor YouTube channel. Basically, we want to look at how to solve three systems of equations, right? Three variables, systems of equations using the Cramer's rule, right? So let's look at this problem on the board, right? So now, this problem, if you have such a problem, three variables, and you have to use the Cramer's rule to find the variables. One, you have to know that this in the matrix form, is 2, 2, 3, 4, right? You write the S column, and then you write the Y column, you write the Z column, right? So we have the coefficient of the Y as well is 1, 2, and -2, right? And then the coefficient of the Z is also -1, 2, and 3. Good. So now, what do we do with this? This should be multiplied by the variables. So in a matrix form, this is how we denote, or this is how we write the three systems of equations in a matrix form. This is how we write it, right? Should be equal to the constant, which is 1 minus 13 and 9. Very, very simple. So when you have three systems of equation, write the S column or the coefficient of X on the S column, right? On this column, on the first column. And then the coefficient of the second variable should be on the second column. And then the coefficient of the third variable should be on the third column, right? Or it's either you go this way, you write the coefficient of the third or the first equation on the first row. First, you write the coefficient of the first row, the first equation on the first row, write the coefficient of the second equation on the second row, and then the coefficient of the third equation on the third row. Either way you go by it is okay. You can maneuver your way and get the variables, the values for the variables. Good. Now, when you are done with that, don't forget that they are attached by variables, right? So on your row, on your column, the X, whatever variables you have been given, should be labeled on the column, right? So we have X, Y, Z as given in the question. And then should be equal to the constant aspect. And that one too is written in a column form, right? So we have 1, 13, 9 there. So that is what is labeled here as well. Good. So now, if you want to find the X, this is how we find the X. X is equal to, S is equal to the dx over the d. Now, what does this dx and what does this d mean? The dx is simply, when you want to find the dx, we simply take off this element, the values or the coefficient of the x, and then we replace it by the constant, right? And then the d is when we want to find the determinant of this 3 by 3 matrix. All right. So now, this is how you find the y as well. The y is also equal to dy over d, right? And then the z is equal to the dz over d, right? So this is basically how we find the variables using the the matrix form or the CRAMER'S rule, right? So now let's find our d. You know, d is running through all of them. So let's find our d first, and let's find the x, the y, and the z. Good. So now how do you find the d? The d is equal to the determinant of this 3 by 3 matrix. All right. So we have the determinant of this 3 by 3 matrix, and that is equal to the d. I'll tell you why it is equal to the d right now. So this is equal to the determinant of this matrix, right? So now you know that you know how to find determinant. All right. If you've already watched my first video on inverse, I really taught how to find inverse of a matrix, and then I explained all the determinant, the transpose, the cofactors. Good. So now let's find the determinant of this 3 by 3 matrix. I'm going to find the determinant of this 3 by 3 matrix, which is 2, 3, 4, 1, 2, minus 2, and then minus 1, 2, and 3. So we want to find the determinant of this matrix, right? So the determinant of this matrix is equal to the d, right? And this is equal to, let's pick the first rule, which is common to us, we always use. It's equal to 2 into, we avoid all the elements on this rule and avoid all of this. So we have 2 minus 2, 2, and 3, right? And then minus 1, we avoid all of this, and we avoid all of this. We have this, and we have this. So 3, 4, 2, 3, and then the last element is minus 1, which we will avoid this and avoid the whole of this. So we have this element. We have 3, 4, 2, and minus 2, right? So now the d, which is equal to the determinant, is equal to 2 into, this will give us 6, right? 2 times 3 is 6, and then plus 4, right? Because this is going to be minus 4. And then you know that on this diagonal, this off diagonal, when you want to find the product of it, it's going to be times a minus again. So it's going to plus 4. And then minus 1 into this times this, which is 9, minus 8, minus 1 into minus 6, minus 8. Good. So now we have determinant of d, which is equal to the d, is equal to t, 2 into 10, minus 1 into 1, minus 1 into minus 14, right? So from here, we have determinant of d, which is equal to the d as 20 minus 1 plus 14. 20 minus 1 plus 14, and that is equal to 33. That is equal to 33. That is equal to 33. So now we have the d, or the determinant, as 33 for all. So now let's find the dx, the dy, and the dz, right? So how do you find the dx? Right. So now we want to find the dx. How do we find the dx? Now the dx is obtained by finding the determinant of d. But then d, we have to change some elements in the d before we can find the dx, right? So we have this now changes to, when you want to find the dx, you substitute the constants in place of the the values for the x, right? So we substitute the constants in place of the values of the x, right? So we have 1, 13, 9. Then we maintain the x and the z. So we have 1, 2, minus 2, minus 1, 2, and 3. Right? So when you want to find the dx, you simply remove the values for the x, which is this, and substitute the constant there, and then you find the determinant, and that will be the dx. So now the dx is equal to the determinant of the x, right? So we take this one, that means we are going to avoid this and avoid this. So we have 2, next 2, 2, 3, and then minus 1, 13, 9, 2, and 3, plus, right? This part will be minus because there is a minus there. So minus 1, minus 1, minus 1, minus 1. Then we avoid this element and we avoid this, so we have this element. We have 13, 9, and 2, next 2. Right? So let's find the x, which is equal to the determinant of the x, and that is equal to 1 into 6 plus 4, right? Minus 1 into 13 by 3, right? 13 by 3, which is 39, minus 18, right? Minus 18, minus 1 into minus 26, minus 18, minus 18. So we have the x, which is equal to the determinant of x, the x, as 10 minus into 39 minus 18, right? And that will also be 21. So 21 we have negative in front of it, so it's going to be minus 21. Then this also will be minus 44. but then we have minus in front of it, so we have plus 44. Good. So now we have the x, which is equal to the determinant of the x as 33. Good. We also have the dx, which is the same as the determinant of the x as 33. Now, we can now find our x. We can now find our x, which is equal to the dx, or which is equal to the determinant of the x as 33 over 33, and that is equal to 1. So we have the value of x as 1. We have the value of x as 1. So now let's continue to find the y and the dx, the dz, to find the value of y and z, right? So now we want to find the y, right? So if you want to find the y, you simply take off this element of the y in the 3 by 3 and then substitute the constant in place of it. So we write this, and then substitute the constant in place of the values of y, right? So we have 2, 3, 4. And then in place of the y values, we substitute 1, the constant, 13, and 9. Then we maintain the z aspect. So now we have the y, which is equal to the determinant of the y as 2 into 13 and 9, 2 and 3, minus 1 into 3 and 4, 2 and 3, minus 1 into 3 and 4, 13 and 9. Right? So now we can now simplify this thing and then find the determinant here of this 2 by 2 matrix, and then we have this will give us 39. 13 times 3, which is 39, minus 18, minus this will give us 9, minus 8, minus this will also give us 27. This will also give us 27 minus minus 13 times 4, which is 52. Which is 52. So now dy, which is equal to the dy, the determinant of dy is equal to 2 into 39 minus 18, which is 21, minus 1 into 1, minus 1 into 27 minus 52, which is minus 25, right? So d, which is equal to the determinant of dy, is equal to the dy, which is equal to the determinant of dy, is equal to, this will give us 42 minus 1 plus 25, right? So this is basically going to be 66. So we have the dy, which is equal to the determinant of dy as 66. So we have the value of y, as dy over the d, which is equal to 66 over 33, right? And this is equal to 2. This is equal to 2. So now let's do the same thing for the z. Let's do the same thing for the z. Let's do the same thing for the z, right? And find the value of the z, right? So now the z, we write the x and the y column. We write the x and the y column, all the elements there. We write them, and then we substitute the constant aspect in place of the z column, right? So we have 1, 13, and 9, right? So to find the z, which is equal to the determinant of the z, is equal to 2 into, we avoid this and we avoid this, so we have 2 next to 13 and 9, and then minus 1 into 3 and 4, and then 13 and 9, plus 1 into 3 and 4 and 2 and negative 2, right? So we have the z is equal to the determinant of the z, which is equal to 2 into 18, this times this, 18, plus 26, because 2 times 13 is minus 26. But on that diagonal, when you are multiplying, it is affected by negative, right? We have plus 26. And then minus 1 into 27, 3 times 9, which is 27, minus 4 times 13, 4 times 13, which is also 52, plus 1 into minus 6 minus 8, right? So we have the z is equal to the z, which is equal to 2 into 18 plus 26, 18 plus 26, 18 plus 26, which is equal to 44, 44 by 2, 44, minus 1 into 27 minus 52, which is also minus 25, right? Plus 1 into minus 8 minus minus 6 minus 8, which is minus 14, So we have the z, which is equal to the determinant of the z, is equal to 88 plus 25 minus 14, right? So we have the z, which is equal to the determinant of the z as 99, So now we can find the value of z as the z over d, which is equal to determinant of the z over determinant of d, and that is equal to 99 over 33, and this is equal to 3. This is equal to 3. So this is the value for z, right? And then we have the value for x2 as 1. We have the value of x2 as 1. So this is simply the process that we go through to find the values or the constants or the variables, the unknown variables in the 3 systems of equations using the CRAMER'S rule, right? Thank you very much for watching this video. I really appreciate your time. Please don't forget to press on the notification bell below, and then I'll keep you updated very soon. Thank you very much. Bye.